Yeah, welcome on board. So, like I said, today we'll basically be talking about writing unit tests in Rust, so that we can see how we can sort of write unit tests to our smart contracts, because in this case, we're going to write our smart contract using Rust. So, how we can basically go about it. And maybe just before you proceed, if you attempted, I know some of us may not have finished, but if you attempted the assignment I gave last week, maybe you can just put up your hand, please, before you proceed. If you attempted the assignment, yes. Okay. Okay, that's awesome. So if you've not, please try and attempt that assignment, because that project is what you're going to build on as you proceed. So you're going to translate that into a smart contract. And after translating it into a smart contract, then you're going to build on it as you proceed. So please, if you've not yet, or if you're facing any challenges, please reach out. I'll be willing to help. I know Rust is sort of buggy, and you may have faced some headache with it. So please just find your way about it and ensure you're hands-on all the time. So today you're basically going to talk about unit tests. So writing unit tests in Rust, or for our Rust programs that we're going to work with. Now, I also hope we are still iterating on our demo project ideas. And if you already have one, then please sort of list down how you're going to go about it. And if you can start working on it right away, well and good. The other thing, we still don't need much for this session. You just need Cargo and Rust installed in your machine, and you'll be good to go. And yeah, let's do this. So I'll just let me see. Okay, let me just open this folder we've been working from. Let me just share this. Okay. So yeah, here. Huh? Which one is that? We're here. Yeah, so this is the folder we've been working from. I hope you guys can really see that visibly. I just increased the font. So this is basically where we were last time. So today I'll just close all these and minimize everything. Yeah, so this is the folder we've been working from. I actually pushed what we did in our previous session online. So if you have a GitHub repo, you should be good to go. You should be able to see what we did in our previous class. Now, in this session, we're basically going to talk about unit test, how to write unit test, and do some very few things with it. Then I'm going to show us sort of a demo project that I'll be building on from my end, that is, but you guys will be building on your assignment. So please, if you've not attempted or you've not started, please get started as soon as possible. Now, to write unit test in Rust, leave alone, just assume the very many files I have in my sidebar. So I'm going to work from this main.rs file like we did previously. So initially, I've been using a different file and importing the content within the main.rs file and basically running them in our main function. So for us to write tests, however, I'm going to configure a test in the main.rs file. In this case, we're going to write all our tests within this main.rs file, okay? And how do we go about that? Now, the first thing we're going to do is use this macro. It's called configuration, test configuration, actually. So that is how you start your tests. Then here we're going to have a mod. We're going to name it tests. And yeah, so these particular or any code that is going to go within the mod tests after we've sort of initialized the module with this macro, this code will only run when we type or we run cargo test from a command line. So if here's what I mean. So if I came here and say cargo test, any function within these module tests is going to be run. You realize that for now we don't have any function, and it is telling me that 0 tests were in. So apparently we don't have any test in place. So we're going to write to a test or a function that is going to do perform a unit test. And to achieve that, the very first thing we're going to do is use this test macro as well on our function. So we're going to write a function that is basically going to perform a very simple test. So in this case, we're going to say, let's call it add numbers. So this function is called add numbers, and it is a test function. You realize, okay, guys, I told you I have an extension in my VS Code that I'm using. I think it's Rust Analyzer. If you're on VS Code, you'll be good to go. You can just search for that and install. That's why you can see I have this help within my file. So I can simply run a test, or I can run the whole test from that point. So don't worry about these. Let's focus on the code. So like I was saying, this function is basically going to run a very simple test. And to run tests, there are some functions or macros that have been exposed to us. So the very first thing I'm going to do is just list them out. Then I'll be explaining in a bit what they do. So the first one is a assert function. So assert function basically requires a conditional expression that evaluates to a Boolean variable. In this case, if that expression is going to evaluate to true, then that test is going to pass. But if it will evaluate to false, then the assert function is going to panic. And in that case, your test will have failed. Okay. So what am I trying to, what do I mean in this case? So let's say we have 8 is greater than, let's say 8 is greater than 3, right? So in this case, we know that 8 is indeed greater than 3. So if I just save that, then come back right here and run cargo test. Don't worry about the warnings, guys. Those are just some things we have up here. We've imported, but then you've not used. So down here, you realize that I'm told I want you to focus on what I've just highlighted. We are told that we've run one test, and the test we've run is this function add numbers. Apparently, it's the only function we have within our test. Then the test result is listed down here. So in this case, we have 1 test that passed, 0 that failed, 0 was ignored, 0 measured, 0 filtered out, and blah, blah, blah. So we'll be talking, we may talk about these other information, what it means to be failed, what it means to be ignored, filtered. We may really not talk about measured for now. So in this case, this means that 8 greater than 3 gave us a truthy value or a truthy Boolean value. And so there was no panic, or this function never panicked, or it didn't raise any error. But if I, if I did that, sort of just changed things. So in this case, I'm saying assert that 8 is less than 3. So in this case, we know that 8 is not less than 3, right? So these should give us a false value, right? And if it gives us a false value, then this assert statement is going to do what? To mark that as a failed test, because it is not true that 8 is less than 3. So let's see what this gives us. Awesome. So here, the test, we ran the test, but then, yeah, we had one test, and the test we ran was add numbers, but then it failed, right? It failed right there. And the failure is the test add number panicked at assertion this 8 is less than 3. So since this expression returned or resolved to a false value, our function panicked. And when it panicked, our test failed. So in this case, we had this function, and our test generally failed. So we had 0 test at first, but then we had 1 test that failed. Now, so that is it about the assert statement. I'll just copy this down here and comment the first one. So the very second function I'm going to talk about is assert equal. So assert equal, we're just going to work with the same expression we've been working with, but then assert equal checks if the 2 parameters you've passed are equal, either in value, that is, if it's a string and a string, they should be equal in value. If it's a number and a number, they should be equal in value. And they should also be equal, they should also be of the equal data type. Now, in this case, okay. The first instruction I passed to tell Rust that I'm carrying out test. Okay, here we go. I hope you're talking about the file, Timothy. Let me find this. Yeah, so from our file, here's how we started by providing this macro configuration or CFG test. Then right here we have a module, and we're naming this module tests. Then inside it, we have this function. And this function is also sort of initialized, or it's also taking a macro test in this case for it to be, we are making it clear to Rust compiler that this one is a test function. So view it as a test function or one of the unit tests you're having within our file, within our test module. So that is how we go about that. So I was talking about assert equal. So assert equal takes 2 parameters. In this case, though the 2 parameters must be equal for it to pass. If any of them is not equal to the other, then our statement is going to fail. So in this case, we can just do away with this, is it inequality sign? Then in this case, I'm going to pass 8 and 8. So here we expect that this test should pass. Why? Because 8 is actually equal to 8. Let's see what that gives us. Yeah, so our test just passed, right? How about I had 8 and 4? Let's see what that will give us. You realize it fails. Why? Because 8 is not equal to 4. Okay. So that is the second statement I wanted to talk about. Okay. Let's look at the third statement, or the third. So these are basically the functions or the expressions you guys are going to deal with in your projects. This is what is going to help you carry out a unit test within your Rust program. So really take note on that. Now, right here, I have assert NE. So assert NE is basically assert that the 2 parameters are not equal to each other. Okay. Yeah. So that is basically what it means. So it also takes 2 parameters. So for it to pass, these 2 parameters must not be equal. or they should not have equal value. Otherwise, if they have equal value, then the test will fail. But if they have different value, it will pass. Now, while 8 and 4 failed in our assert EQ, it should pass in our assert NE. Okay, let's see what that generates. Awesome. So you realize here it passes. Why? Because 8 is not equal to 4. But then if I changed this back to 8, so in this case I have 8 and 8, these should fail. Why? Because 8 not equal to 8 is not true. So it basically resolves to a false value. And in that case, our statement panics. Yeah, those are the main, I'd call them the main statements or the functions you guys are going to interact with. So that is how simple or how basic you can write a test in Rust, right? I'm just going to give us I'd call it a bonus, but then you can research on this. There's this macro should panic. So should panic, let's say I had a function in my main.rs file. I had a public function right here, and I'm saying, what should I call this guy? Okay, okay, let's just call it sum or add some number. Then I'm going to expect you to provide the number. In this case, I'm going to take to go with the default. So num I32, that is unsigned integer. So this one is going to be a void function. So I'm going to check if whatever number you've provided as the parameter is greater than, say, 50. So in this case, if it is greater than 50, you're good to go. So we can basically do 50 plus 50, right? 50 plus 50. Then you can basically return that value. So we're returning I32. So basically 50 plus 50, the sum of 50 plus 50. Now that is a, oh, sorry. The value of num should be what you just put there. Might be missing an L. So let's provide this and see if it will resolve the error. So in this case, you're saying if the number you've provided is greater than the value 50, then go ahead and find the sum. So this it basically doubles the number and give us the value. But then if it is less than, we want you to panic, okay? So by panicking is like, now this is like a try and catch block in JavaScript or in Python and the Java, the language you guys are familiar with already. So this is because we don't really have that structure of a try catch block in other languages in Rust. This is the simplest way you can put it. So you basically check if value is valid, else you panic. Now, if you panic, the whatever you had executed will be rolled back. And by rolling back, I mean, if let's say we had some statements here, it will basically be undone. Okay, so there's, by panicking, everything you did within that function will be undone to their initial state before the panic occurred. So that is basically what I mean. So here we are panicking and we are saying number is less than 50. So this message will basically will be shown to us. Then we are, let's return 0 as the default in that case. So yeah, in Rust we don't need brackets, guys, while writing if functions. I think we saw that in a previous class. Awesome. So that should work. So in this case, if I come here and I wanted to test this function, add some number. Now, the very first thing I'll have to do is import it within my tests module. And how do I do that? I come right here within my tests module. and I import it as I use super, and I'm basically importing everything from the super. So super is basically going to give me all functions in my main file except the tests module. Okay, so every other function from here upwards is going to avail it to me. So that is how I just imported that as it is in line 46. Then I'm going to use it within my add number test function. Okay, so this is how I'm going to use it. So the very first thing I'm going to do is let's get a function and let's pass in 60. Let us start with what is valid. So in this case, if I, what is happening? Okay, so in this case, if I went ahead and ran this particular test file, 60 is doing what? Is meeting this particular criteria. So 60 is basically greater than 50, right? And so it is going to go ahead and do what? Add 60, or rather double 60, and give us back the value. In this case, you're going to have, we can just store it somewhere. So let sum be equal to that, okay? So in that case, we just stored the value somewhere. Now, since this is going to pass, and we indicated in line 49 that it should panic, then this test is going to fail, okay? So why is it going to fail? Because we expect it to panic, but then it is not going to panic. Based on the argument we've put here, it is not going to panic. But here we expect it to panic. So in other words, the test is going to fail. Guys, I really hope I'm not confusing you. Yeah, so that test just failed. Okay, as you can see right there, it just failed. So what if we made, or we provided a value that is going to make this function panic? In this case, we're going to pass in 20. Let's pass in 20. So 20, if I get back to our function here, 20 is not greater than 50. So we expect this statement to be executed, right? In other words, we expect it to panic. Now, coming back to our test, since we expect it to panic, in this case, should panic, and we've actually provided a value that is going to cause our function to panic, then this test is going to pass. Let's see what that gives us. You see? So here, our test just passed. Why? Because we expected it to panic, and yeah, it panicked. So that is our test passed. Now, that is another way you can write, or you can sort of configure your tests in Rust. Now, back to assert statement. Now that you know how to work with all these, back to assert statement. Let's say you wanted to check if a particular expression is actually evaluating to a certain value. In this case, we can say, let's say we had 5 plus 3, and we wanted to check if this, sorry, let me use assert equal in this case, because it best fits this case scenario. So I have 5, and I'm adding 3 to 5. So I expect that 5 plus 3 should be equal to 8, right? So I'm basically trying to affirm that that 5 plus 3 is actually 8. So what happens if I try to run this? I definitely expect this should pass. Let's see why this failed. Oh God, there's a lot of error right here. So we are setting that 5 plus 3 should be 8, right? This is I32, I32, I32. Why is this not passing? Let me see. So it's So these, oh, we need to get rid of these guys. We need to get rid of these macro should panic, because in this case, you're expecting whatever you're running to panic, but that is not panicking. So I think that is where the issue was. So let's try run this again after commenting should panic out. This time around, this should bring us something awesome. So in this case, our test just passed. And I wanted to draw attention to something. There's a statement, if you're so keen into what is printed on your terminal. I don't know if I can just enlarge this and scroll up somewhere here. Let me try making this fill. See if I'll get that particular statement. Try run again. Yeah, so I wanted to show you this. If you use a sat EQ, in this case, a sat equal and a site NE or a sat not equal, and it fails, okay? There's a very important or a message that is going to help you debug your code in this case, giving you basically the parameter on the right and the parameter on the left. Now, other than these description of our test given at the bottom, I want you to focus on this part, okay? So we are told that in this case, our add number test function failed, okay? So in this case, it panicked. And then you are being given the values on the left, that is the left, the value on the left, the first parameter. Then the value on the right, that is the second parameter of that assert EQ function. So the value on the left was 8. In other words, 5 plus 3, what that evaluated to 8. And the value on the right was 7. So even from what you can see from your terminal, you really know that 8 is not equal to 7, right? And so that is why we have the error. So that really helps when it comes to debugging your program. And generally, the software you guys are going to work on. If you have any question, please try. You can put up your hand, or you can just put them in the chat. I'll occasionally be checking the chat to see if there's anything. Awesome. So that is the basics of writing unit tests in Rust. Now, there's someone who reached out to me asking why their test was failing. I don't know if you're here, maybe you can just raise up the issue so that we respond to it. Christopher. Christopher, are you able to solve the problem? Maybe you can just confirm that either by unmuting or you can just put it in the chat. If it persists, we can see how to go about it. So, okay. Yes, Philip. Philip.
Okay, I have a question. So after we assert the values, is it possible to use a return statement so that we can get the value? So in this case, let's say we return a print statement. Is it possible?
We return a print statement.
Yeah, for example, after we have asserted that 5 plus 3 equals to 7. So maybe, is it possible we use a print statement that says 5 plus 3 is not equal to 7?
Oh, so you want to add some message to your test? Is that
yeah, I'm asking if it's possible. Yeah.
Yeah, let's find out. So in this case, the test should fail. So let's expect this to fail. Expect to fail. Maybe you can just provide that message there and see if this is going to work. So from our terminal, let's see if that message that just printed out. I really can't see it anyway. I can't see it. Oh, okay. Okay, let's first see if these are, if it passes, whether it prints it or not. Because there should be a way. So this one is not printing. This one is not printing the. It's not printing the message.
So can we use a print line statement?
Okay, print line statement. I doubt if it will work. Sorry, because while the test is running, it is basically sort of, okay, if it detects that there's something printing, it will basically collect it. So it won't show it on the terminal. Okay, but let's just see if let's see if that is actually true. So I'll just copy all these from that point and put it over here. Let's see what these does. So it just finished. Can we see that value anyway? Just expand these. I can't see it anyway. I can't see it anyway because it was collected while the tests were being run. So it detected that something was being printed on the terminal, but then it sort of collected it. So it prevented it from actually being shown on the terminal. So that is basically what is happening. However, okay, if you're having, let's say you expected an error to occur somewhere within your code or your function. So in this case, I can come here and say, let me just use this function I used previously. So this function is basically panicking with a message saying that the number is less than 50, right? So if I were to test for this, if I were testing this function and I expected it to panic at any given point in time, in my test function, I'd first of all use that macro. Then let me just comment out all these for now and bring up our, so that is the function I'm talking about. So this function is expected to fail, right? But then it is going to fail with a certain message. That is, if you are, okay, let's assume you had several panic statements within one function, but then you're testing for a particular, failure within your function. So in that case, you'd simply come here and provide the the message you expect the function to panic with. So in this case, if it is going to panic with this message, then your test is going to pass. If it is going to panic with a different message other than what you've specified, then the test is going to fail. Okay. So let's see if these are, let's see. Okay, what's happening? Let me see if I got these right. Yeah. So in this case, it panicked, but then it panicked to this particular string or statement. And so that passed. What if I came here and sort of changed these all statement and say, let's say we went with something else, okay? So in this case, The function is going to panic, yes, but then it is not going to panic with the expected message in our test function. In this case, number is less than 50. It is not going to panic with this particular message. So in that case, this test will fail, or rather we expect it to fail because whatever we are testing is not actually shown to us. Or whatever we were testing was not met. Okay. So it is still passing. It is still passing. Let me just confirm this.
Is it because of the value 20?
No, the value 20 is what makes our function to fail. In other words, panic. Okay. So we expect it to panic, but then with the message depends on what is going to be executed, right? That message should bring the whole difference. Let me just check these. Man. Okay. Okay. Let's try this. Yeah, so now it failed. I think we just missed the parameter naming. So the expected string is number is less than 50, but then what it finds is something else, a string, something else. So in that case, this test fails. Why? Because even though we provided a value or a parameter that is going to make our function panic, it panicked with a different message we were not expecting. And so that is what made our test to fail. So if I were to revert back to whatever we had initially, in this case, number is less than 50, and we attempted this again, you realize that now it passes. Why? Because the value number is less than 50 is equivalent to what, or to the message our function actually panicked with. So I really hope that is clear. Philip?
Yes, yes.
Awesome. Timothy, I also saw your hand up. Timothy? Okay. So let me check the charts. Okay, Christopher, there's a, okay. When it comes to Rust, we have what you call binary projects. In this case, you're building a main software, okay? Then we also have libraries. So you could be writing a Rust program, but then this Rust program is going to be a library. In this case, it is going to be used in other Rust programs, if I may put it in a layman's language. So you're basically writing a library. It's like you're doing a node library. So you're doing a node library, pushing it to npm. You're adding it to the npm packages online. Then whenever anyone wants to use your library, they just do npm install and the name of your library. So that way they're able to utilize it within their programs. Now, if you if you're, let me just clear this. So if you want to set up a Rust library project, then you need to do cargo new and the name of your project. But then you provide this particular flag lib. So this one is going to create a Rust project, but then this not a main project, but then it's going to create a library, a Rust library project. So while we're going to deal with the smart contracts, we basically are going to write libraries or Rust libraries, okay? So these are functions that are basically going to be called from other, sorry, we're writing programs that can be utilized in other programs. So you could basically, using the libraries you're going to write, depending on the architecture of the NEAR protocol blockchain, there's a way they are importing these bytecodes as libraries within their code somewhere, depending on what how they've structured it. Then that way they're able to invoke the functions that are available within your library. So the difference is how we initialize our project. But then when it comes to writing tests, everything should work as expected. Okay. So I really hope that explains something. So I'll just clear that out for now. Then I wanted us to go through, there's a very simple project I came up with that I wanted to show us for us to get these well. So what did I call this now? Or somewhere here. Awesome. So here's the project. So let me just walk us through it first. So if I close every file I have right here, so this is basically the project I wanted to show us. I named it wishlist. So in this case, we're basically coming up with a program that is going to sort of store records on what you wish or your wish. In this case, we're going to store records on vehicles or cars that you wish to maybe buy or put in your cart and all that. Now, the very first thing I did is I implemented a structure for the vehicle, or the structure my vehicle object is going to take. In this case, you realize I decided to use public, or rather expose the content or the instances of my vehicle just for the demo purposes, or what I wanted to achieve in the test. So I simply exposed that. So our vehicle is basically going to have a name, model, mileage, year, and price. And you also take in note on the data types provided right there. Then I just provide these function, the new function that is going to help me initialize the vehicle object. And in this case, I'm taking all these parameters within my new function, and I'm using them to create a vehicle object, which in this case, I'm returning back. Okay, so I'm basically creating that and returning it back. So I have a return type of type self right here. So that is basically what I'm doing. And right here, I'm returning, these should be self. Okay, unless otherwise, let's see what the test is going to tell us. So I'm basically returning an object of type vehicle from that file. Then here in my user.rs file, I've made use of hash map. So I'm basically importing hash map from standard collections. Now hash map is if you know what data structures are, the likes of map, the set, and all that. So you really know what a hash map is, okay? So I decided to use a hash map as my database, or rather what I'm going to use to persist my data, as long as during the execution of this particular program. So that is what I'm going to use as my database. Then I'm pulling in the vehicle class or structure into this particular file. Then here I define user structure. In this case, we're going to have email and vehicles as our instance variables. Then email is basically going to contain the email of whoever the user is. Okay, so it's basically going to help us uniquely identify the user. Then the vehicles is where we're going to have the hash map object. So this is where we're going to store the information about the vehicle that the user is going to store in their wish list. Then from line 11, I'm basically implementing that particular structure. So basically adding some methods or behaviors to it. So the very first thing I do is basically initialize the object with the right values. In this case, I only require the email of the user, and I'm providing that email to the instance of these as required for this particular object. Then I also initialize the vehicles variable or instance variable using the hash map initializer function, in this case new. Then from there, I now define my functions, what I just highlighted. So I basically have 3 functions right here, guys. Other than the new, that is the constructor function, I have 3 other functions right here. So the add function is basically adding a vehicle to our hash map or to our database, okay? So in this case, I'm collecting this information from the user, or I expect this within my, I expect this information while before initializing a vehicle object. So I basically expect you to provide all this information, the name, the model, the mileage, year, and the price. So after this information is given to us, right here, I basically, sorry, right here, I'm basically creating a new vehicle object over here. So I'm creating a new vehicle object using our new function, this particular function right here. And we are passing in the parameters that have been provided in the add function. So that is basically initializing a vehicle object. Then down here, I'm inserting this vehicle object to my database. In this case, the hash map collect data structure that I'm using. So I'm basically doing vehicles.insert. In this case, the key is the email address of the user. Okay, so key, here's the key. I'm basically getting this value from the email address that the user provided while initializing the object or the user object. So that is basically what I'm using right here. Then I'm passing in the vehicle object we just created up here. Okay. The vehicle object we created in line 21. So that is it about the add function. There's nothing we are returning, it's a void function. Then our show function is utilizing an enum. So in this case, we are using option enum. If you read, there's a book I shared with you guys in the group. Let me see what the name was. Rust Programming Language by Steve somebody. So please go through that book. You're going to get more information about the language, and you're going to understand all these intricacies. But option is basically an enum. There's a way it is structured, and it is obviously used in Rust programming languages. That's why you realize I've not imported it anywhere and I've not defined it anywhere, because it is sort of built in the language, so you can simply use it. Okay, so I'm using it and I'm returning a value of type vehicle. We're going to see how we can handle this particular the information returned using this particular format. Then right here, I'm retrieving the vehicle record from my database, in this case, vehicles database. I'm simply getting it using the key, in this case, the email address of the user. So whatever information that is going to be returned back to me is going to be information about a vehicle object. So I expect some value from these, from whatever is going to be returned. It is also returning to me, it is returning to me some value wrapped in these, in an enum of this type option. So that's why I'm using this sum function. So the sum function is basically going to contain the data I need, the actual data I need, in this case, the vehicle object I need. And I'm simply going to return the same thing returned to me, okay? So I'm just going to wrap it up using the sum function, and I'm just going to return it as it is. If nothing was found, then just return none. The remove function is basically going to remove a vehicle record from our database, in this case, the hash map. So I do self .vehicles. So basically using our database, then I'm performing this function remove, passing in the key of the data I want to remove, in this case, the email address of the user. So that is basically how our object is, that is basically it about our object. I'm going to push this code to a GitHub repo, and you guys will have access to it. Now, let us come to the main function. Now, without even looking at the test first, let me draw our attention to the main function right here. So this is where we're going to execute our, we're going to interact with whatever I've just talked about. That is the user object and the vehicle subject and all that. So the very first thing I'm doing here is initializing, or rather, initializing an email address. So in this case, I'm going to use Kevin at gmail.com, sorry. Then using that email address, I'm creating a user object using what? User new function. In this case, this initialization function I just showed us, guys. Hope I didn't do any mistake that is going to cost us. Okay. Yeah. So I'm basically initializing the user object in line 12, sorry. Then line 16, I'm simply naming, or giving a string representation of the model of the type of car we're going to add to our wish list. So in this case, it's going to be RAV4. Then I'm invoking from the user object we've just created in line 12, I'm invoking the add method of that particular object, passing in the necessary parameters, in this case, the information about the car we want to add to our wish list, as I described right here. So we're passing in the name, in this case, Toyota, model RAV4, mileage 0, that should be brand new, year 2022, price approximately, that's about 5 million. Now, these are float data. It requires a float data type. Realize if I just went ahead and put 500 and saved, there's an error, right? Why? Because that is not a float. So for it to be a float, I have to add some decimals somewhere just to indicate that, hey, that's a float. Then after adding that particular car record, we basically want to show it, or rather print it out, okay? To see if it actually added that particular record to our database. So I'll basically, hey, what's happening? I'll basically run cargo, not cargo test, but in this case, cargo run, because we are running the function before we proceed to the test and see what's printing. So in line 14, I just printed out the email of our user, and that is what printed right there, what I just highlighted. Then in line 19, we printed out the object, that is the vehicle object that was stored in our database. And in that case, I don't know if you can see this down here. That is exactly what we've printed. So in our database, we have a vehicle record with the name Toyota, RAV4, mileage, and blah, 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 all that put inside there. So that is basically what we stored in our database. And that is all this program is doing. Very simple. Now let's jump to the tests, because that is what I wanted to show us. So in the test, I'm going to test if my program is actually doing what I expect it to do. Okay. Now to test if it's actually doing what I expect it to do, here's how I'm going to go about this. So first of all, I'm importing the user structure. And this is how I import it, guys. Use create. Now create is basically, it's like the main file, okay? Our program is going to run from. So create, then from create, we pass in the file user. So user is basically this file user.rs. Then this user, you realize it as capital U, is the structure we defined within this file. In this case, this user. Then the same thing we are doing to vehicle. It basically follows that pattern. So like I said, this is how you initialize your test, put it in the test module. Then I just brought in my object that I explained earlier. Then from this point, I'm basically going to write test functions. Now, the very first test function I'm writing in this case is create user object. So I'm basically going to test if I'm using the user class or the user structure, I'm actually able to make an object out of that blueprint, right? So I have an email address right here. Then I'm using the new function of our user structure to initialize a user object. In this case, that. Then I'm using the assert equal function to affirm that the email address that we provided in line 30 is actually equal to the email address that is in our user object. That is the user object we've just created using that email address, okay? So I'm actually trying to see if these two values are equal, okay? So I'll just hit on this link over here. This is just a shortcut, guys, for me to run this particular test and not the others. So that one just passed. So here's the result. So that just went on successfully. Why? Because we are told that we had one test and one passed and there was none that failed. So in that case, I successfully created a user object. After creating a user object, now moving on to testing whether adding a car to my wish list is actually working on well. I basically bring in the procedures in my first test, that is creating the user object, and that is how I go about that. Then in line 40, I'm defining the model of the car I'm going to use. Now, there's a reason why I'm storing these values separately, guys, or sort of in a variable, the model value, because I'm going to use it somewhere within my test. So if I just pass it straight within the parameters, I may not be able to achieve what I wanted to achieve. So that is why I'm sort of separating it out. So I'm just declaring that in line 40, the model. Then line 41, I'm basically adding a car to my database or our hash map, in that case, the vehicles. So I pass in the information, as you can see right there. So that is the information I'm passing. After passing this information, then I expect that in my database, I should have one record and only one record, okay, of the car I just added. So that's why in line 43, I'm asserting to see if the user vehicle's length, in this case, the instance variable within our user object. So I'm asserting to see if the length of that particular data structure, in this case, hash map, is exactly equal to 1. Okay. So if that is the case, then my test is going to pass. But if it is going to be 0 or any other number, then my test will have failed because it is not what I expected. Then moving on to line 45, you realize I have a match statement. We talked about these in our previous sessions. Now, match statement is basically going to help me test the cases of whatever value is going to be returned when I try to retrieve a vehicle record from my database, in this case, the hash map data structure, okay? So I'm basically accessing that user vehicles dot get. So get is basically a method of a hash map data structure that you can use to get the values depending on the keys you stored them. That is, if you provide a key to this particular method, you'll be able to get the value that is stored under this key or against the key you've provided. So the key in this case I'm using is the email address of the user. So that is basically what I'm passing there. Then what is going to be returned back to me is it is taking the structure of an option enum. Now, again, I'll encourage us to read more about that. You're going to see, you're going to understand more of how to go about that. So the very first case I'm testing is if something is actually returned back to me. In this case, if it is, I'm going to retrieve the vehicle object and I'm going to assert that the vehicle object returned to me, in this case, its model is actually equal to the model we defined up here in line 40, okay? So in line 40, we declared a model and we gave it a value, model variable, and we gave it a value. Then using that value, we sort of, using the add function, that is, we sort of created a vehicle object using it. So we expect that whatever is in our database, the vehicle record in our database should have a car model that is equivalent to the model we defined up here in line 40. So that is basically what I'm trying to do in line 46. So if nothing was returned to us, I'll just print out failed in that case, okay? We just print out failed. So that is it about our add to wish list test. So I'm just going to run this and see all that is going to work. And you realize it all worked. If, for instance, I were to sort of, if I were to change this in a way, okay, so that instead of the model we defined up here, let's say I just provided another value for the model, and I try to affirm that the value of the vehicle stored is actually equal to this string model. So if I try and run this should fail. Yeah, that just failed right there. Sorry. So that just failed. Then the last, sorry guys, the last test I want us to study is this. We're already eating into time. I'm really sorry for that. The remove from wish list. So from line 55 to line 58, we're already familiar with that. We're already familiar with what is going on right there. So we're basically using the user's email to come up with the user object. Then we declare the model and we add the car to our database. Then line 60 is affirming or confirming that after adding a vehicle record to our database, the length of that database or the capacity, it should be the length. Capacity in Rust is something else. So the length or the total number of values stored within our database should be 1. So that is basically what we are affirming in line 60. Then line 62, we are invoking the remove method of the user object to remove the vehicle record from our database. So in this case, our database should be empty. Okay. So we expect in line 64, we're basically testing and expecting that the length of our database or the size of our database, in this case, the vehicles, the records in the vehicles hash map should be 0. So in other words, the length should be 0. Why? Because we removed the record we initially stored, as you can see in line 62. So if we run this, let's see what comes up. Great. So if we run that, the test passes. Why? Because every one of these assertion statements passed. So our test passed. Now, I'm just going to show us what if instead of running these tests one by one, the way I've been doing them, what if you just wanted to run them at a go? You'd simply come and write cargo test from your project root folder, that is. So if you run that, it should be able to run the 3 tests in this case, as you can see from the terminal. So we just ran 3 tests. In this case, they remove from wish list, add to wish list, and create user object, and they all passed. None of them failed. The other thing I'd really stress on or bring to light in this context is all these tests, in this case, all these functions within the test module are being run parallel to the other. Okay, so that's why I know if you're so keen, it might have come up as a question, or I'd expect it to come up as a question. Why do I keep on creating a new user using the same email in every of these functions? You see, so it's because I could as well get these out of these test functions and maybe just write a function that is going to help me do it. But I purposely included them within the test function to show us this, that these functions are being invoked parallel to the other. So in other words, they don't depend on one another for at any point in time during the execution of the unit test. So yeah, that is it about the unit test, guys. Apparently, our wish list can only store 1 record of vehicle, but I'll be tweaking it a bit so that we can have a lot of multiple vehicle objects stored within our database so that we see how we can achieve that easily in Rust. So that is it about the test, guys. I don't know if there's any burning question anyone has. Any burning question you guys have, or anywhere you feel you've not understood well when it comes to writing tests, you can just lift up your hand and put it up. Okay, someone is yes, Cosmos.
In the production environment,
Yeah.
in the production environment, for example, in a blockchain, what does the test help for?
Well, tests are going to help you particularly test your smart contract before deploying it on the blockchain. Why? Now, if you're writing a blockchain application, right, and you're looking forward to deploy it on a mainnet network. In this case, we're talking about the near blockchain. So you're going to deploy it on a mainnet network of the near protocol blockchain. Once you make that deployment and you deploy it with errors, okay, making any critical change within your smart contract may cost you considerably a lot of money. So let's say you are writing a smart contract, there's a way you structured your states. In this case, you had a database or a persistent collection, just something like hash map or map or vectors within your smart contract. But then after deploying it on the blockchain, you realize, hey, I think I missed something, then you wanted to make a certain tweak that is going to interfere with the initial state of whatever you deployed, it will cost you, or you'll have to sort of delete that account and recreate it, in which case you'll be using funds, because anything you do on blockchain is involves money. So you'll have to recreate that particular account, then redeploy your smart contract to the blockchain now. So these are some things, these are some of the things using the unit test or the writing test to your smart contract is going to help you prevent. Okay. The other thing that is where, or the other scenario where test comes in handy when it comes to smart contract development is after writing your smart contract, for you to actually see or interact with it. Sorry, Cosmos, could you please unmute?
I can't.
Okay. Okay. So I was saying the other case scenario of you writing test to your smart contract is you see the way we've been doing the Rust programs and running them from a command line, right? Now, if you're doing a smart contract that is going to run on blockchain, then for you to test it, it has to be on blockchain anyway. So you have to run it on blockchain. That means any change you make to your smart contract source code, you must compile it down to a bytecode or build it, then deploy it first to the blockchain. And that is why we have testnet for the NEAR protocol developers. So there's a blockchain network purposely meant for test purposes, okay? So you can do your smart contract and deploy them, then run them. So that is a bit hectic. That is a bit hectic. It's kind of a process. So if you go for tests, that is you write smart contracts. You write tests to your smart contracts. I keep on confusing that. So you write tests to your smart contracts. You can just do that easily out of the box. So you don't need to go through, building, deploying, and running the functions from your terminal. You just write the test, and by running cargo test, you're good to go. Everything runs as if you're on blockchain. So those are two main functions why tests comes in handy while doing smart contracts. You don't want to make any mistake and take that mistake to a blockchain network, because it really can cost you a lot, or those who are going to use that particular solution in that case. So any other question you guys have? Okay, I can't see any other question. So I'll just insist on you guys doing the assignment I gave you. Try do your research as much as possible and come up with a particular solution. It's a very simple software with only, I think there are 5 functions, if I'm not wrong, just 5 functions. Figure out how you can implement it. And because that is what we're going to now implement on blockchain. We're going to proceed with that. Yes, so I can see hands up. Yes, Cosmos.
So my question is about the project.
Yeah.
Because maybe I may overthink and I'm trying to build something with states, things like that. So are you checking whether we can program those functions, or do we have to provide something like states?
Do you have to provide, sorry?
States. I'm talking about state.
Well, okay, what I need. Yes.
For example, I mean, if I have a program, yes, I can register, I can do all those functions separately. Do you have to provide a function whereby I can create and update the same user? Like states, I'm talking about states.
Well, you don't really have to persist the states, please. So that should not worry you much.
Yeah, because I was worried about the states a lot.
No, you don't have to. You see the way I've persisted mine within this wish list program. I'm basically using the hash map collection. So in this case, once my program is executed, whatever I keyed in is no longer there. Why? Because it was just held in the primary memory. of my computer. So once the program is done running, they're also gone. So you don't have to worry about persisting the state of your users and all that. Just do a simple program that you can make use of a hash map, vectors or arrays during the execution. So the states should be persisted during the execution of your program, but after that, they should not be persisted. We'll see how to do that on blockchain and how to persist them so that you can even come tomorrow and still find them there. Okay.
Okay, then.
Yeah, so that should not worry you right now. There's another. Yes, Samson.
Good evening.
Good evening.
I'm sorry, I think last time I left early. So the method of submission, there's an email. Do we send a GitHub link to the uploaded repo or just zip the folder and send?
No, you just push your work on GitHub, then provide us the link to it.
Okay. And I was just curious, when you are coding, do you save the files manually or because?
Okay, from my end.
Yes.
Yeah, I do save them manually. Sorry, guys, I think I've been missing that, but I usually save them. I do save them manually. I just press Control S from my keyboard.
Oh, okay. There's an autosave option. I think it might help to speed up your coding.
Okay, is it an extension maybe?
No. Just go to the top left file. Yeah, there.
Yeah.
Then there's autosave.
Oh, yeah.
Yeah.
So if I make any change, oh, nice. Yeah, that works. Yeah. Awesome. Thank you so much, Samson. Thank you so much. Actually, guys, I'm also learning some things from you. The other time I learned how to clear my terminal, right? Control L, and today I've also learned something new. So I think it's also good to learn from you. I really appreciate that. We're building one another. So is there any other question before maybe we call it a night or a session?